Okay, let's go with problem number 2. It says, with before and after scores of A going to F, B going to G, C going to H, etc., test the relationship. Okay, let's go into the calculator. It's the same calculator as before, but now it's like improvement of scores. So let's do something like 12, 13, 15, 16, 19. And then over time, we'd expect scores to go up for most people in some, maybe it's a test or something. So like 15, and then maybe this person went down, and this person went up by quite a bit, and then this one went up by a little, and then this person went up by a bit. So now I can see that I have group 1 of some kind of scores or something, and then here's group 2 that has some kind of scores, and they went up over time. And this time, since it's a relationship between the two, and the two groups are paired, this would be a paired t-test. Calculate now. Okay, getting some p-values, getting some information, t-scores, and it's telling me that it's not quite statistically significant because it's not close to the 5%. Okay, let's try again. Let's try something like maybe, let's see, changes over time. What could I do? Maybe weights. Let's go. Somebody weighs 150, 120, 210, 195 pounds. They go on a diet, and then this person goes down to 142. This person goes down to 118. This person didn't do so well, went up to 225, and this person had a dramatic weight loss, went down to 165. So again, I have before and I have after, and I can see that people on the diet program or through this pill lost weight in general, but somebody didn't. But they're paired again, right? They're paired because they're groups of data with before and after scores. Calculate now. Not significant, big p-value, low t-score. Okay, I'm kind of getting this calculator down. I got this figured out. So, let's make up a problem. A group of students take an exam and get scores of 12, or let's say 87, 65, 54, 67, and 71. So these aren't very good scores, right? We'd like them to be a bit higher. The 87 is good. They take a prep course and then retake the exam and get scores of... the other person had a high score to begin with, so let's say they stay about the same, maybe dip down a point, but that 65 improves to a 74, and that 54, maybe they improve up to a 71, and then that 67, they improve up to a 72, and maybe the 71 stays about the same, maybe they improve by 1 point. So I got some before and some after scores, and let's run a test. The test would be something along the lines of hypothesis, H sub 0, test scores stayed the same versus some kind of alternative hypothesis that says that maybe scores improved. In other words, the second mean, the mu sub 1 average test score, was actually lower than, significantly lower than, the improved scores afterwards, some kind of mu sub 2, versus the alternative over here, which would have been something like saying mu sub 1 is equal to mu sub 2. Mu sub 2. Okay, getting the idea. So now we go through and we try to run the test. Let's say we run the test and we need to find a t-value, t-score, and then we're going to find a p-value. And let's go run these. Go over here, open up the calculator that we had, go back, and the first group, the before scores, were 87, 65, 54, 67, 71. And then after the prep course, I'm getting scores of 86, 74, 71, 72, and whoops, can't really see it, 72. We run the test, a paired t-test. We calculate now, and I can see a two-tailed p-value of 1247. I noticed that I was only doing a one-tail with a less than. So So my t-score would actually end up being half of the 1247, which would be a point, or sorry, not the t-score wouldn't change. The t-score would be down here, this 1.9375. 0.9375. Now, because it's a one-sided instead of two-sided, I'm going to take half of this proportion, or half of this p-value. So instead of 1247, we'll do something like half of that would be about a 0.062-ish, right? And plus an extra point. That's 0.062, about 6% or something like that. So is that lesser or bigger than 0.05? Well, that's bigger than 0.05, which means it's not statistically significant. So I fail to reject the null. I do not have evidence that the scores increased due to the prep course. Well, so I guess we'd have to change the prep course, huh? It didn't really work very well. So that's how we would do a comparative